As I said earlier today at the beginning, we have really, this was a day and a half of material. We squeezed it in. We managed the time the best we could, but this was a lot of material. So I'm giving you a day and a half of summary now, not a day's worth. Okay, I started the day with having you consider about whether or not, or imagining a data center with no storage. And of course, that was said in jest in terms of the physical amount of storage, because the data storage is tripling in that period of time. But but from an application vendor point of view, an application programmer point of view, where he might start looking at, we're projecting that application programmers will start thinking just of memory. Everything is in memory. And the system will take care of anything that is taking memory and putting into storage. So storage becomes more invisible, and memory starts becoming more visible and the primary interface to developers. Then we had our keynote where Zvonimir came up, did a great keynote. I was very, very, very pleased. He talked about exabyte scale computing. He really talked about very tight coupling of big and fast data, and how purpose-built hardware, particularly accelerators, were going to take a more active role in the data computation. We talked about two different points of view. One is making memory close to computing. We talked a lot about that today. The other was take computing and putting it into memory. The interfaces, he talked about, DDR continuing, of course, then C6, OpenCAPI, Gen Z, and we won't talk more about that because we had presentations on those later. Also, the PCIe and NVMe phenomenon, what's going on. For memory fabrics, he talked about RDMA, of course. He also talked about global memory fabrics, where it's more of a shared memory model, and talked about the latency considerations of these talks. And then the ending part of it was an analysis about, given the topographies, the latencies, the amount of scale, just what does that mean in terms of physical size, in terms of interconnect, et cetera. It was a great, great, great job, I thought. Then we went on with Andy. And Andy has had plenty of opportunities to have his head expanded today. Everyone has said wonderful, wonderful things about him. He talked about the history of the programming model. He talked about DAX and how DAX, and the programming model is not APIs on purpose. How DAX really did create a common model, and how, using both Windows and Linux as an example, they use almost the same structures completely. It's, from an application point of view, building applications that operate on either one is a relatively simple task. And it certainly could have been very, very different had the model not come in. He also mentioned that VMware was coming in very quickly. He talked about demos that happened this year, big demos of persistent memory by both SAP and Oracle in a very major way at their large industry events. A proof point that this technology is getting very, very close to come out. He talked about the PMDK, how that was the MVML. MVML was renamed into PMDK. It's industry neutral. It's supported on both Intel and ARM CPUs today. And he also talked about the JVM project, the Persistent Memory Aware JVM, and how that is under development. And we'll talk more about that after we get to the application panel. Ongoing works on persistent memory over fabrics and security. Then Amit Goldemar from NetApp came up, talked about the ZUFS file system. It's an open source project, supports zero data copy. It has a very, very high level of cache affinity and is NUMA aware. Performance scales very, very well with IOPS. It's been a long day. While remaining low latency throughout the duration. Then Neil Christensen from Microsoft came up. He talked about how NTFS supports persistent memory today. He talked, once again, persistent memory is zero copy access. It was implemented in 2016, it's been shipping. and that there's been enhancements that have been coming along. And he went over a few of those. I copied just a few of the many he talked about. New flush APIs, hardware specific. You're using an example, for instance, if something's battery backed up, you may not need to flush. So as an example. He also talked about flushing versus draining to support parallelism. Draining is a more continuous process, I believe, of the flushing, maybe automated, if I got it right. If not, he can set you straight after. I'm dead on line here. He talked about large and huge page support, and then talked about ultra huge support is coming. He talked about journaling is now DAX aware, and how that and that combined with actually what Tom said later, I think fit together very, very well, giving large, very, very performance impact to journaling. Tom later clarified it, I think, to see the tail of log. Journaling was particularly impactful. And that there's new device models, supporting NVDIM ends, type P, and 3D crosspoint. Then we moved over to Paul Gruen, and it's the PMOF session. Paul talked about 3 usage models. Most of the work to date has been in the high availability usage model. The white papers that we have written are high availability. Paul introduced 2 additional ones. One was remote persistent memory, like a pool where multiple computers are accessing the memory in parallel. And then shared persistent memory, which was, I think those 2 are actually similar, but yet different. But he had increasing it from the one model that we've been focused on to expanding it out. Knowing Paul, I know that we also expect that over time, there will be additional models that will come out for how persistent memory over fabrics will evolve. Stephen came up next, and he talked about that persistent memory. His definition of persistent memory was low latency, using memory semantics, and has storage features. The persistent memory over fabrics is all 3 of those, plus has fabric support. He also talked about Gen Z, C6, and OpenCAPI will merge into one. So a prediction that there will not be 3, but there will be 1. We'll see. And persistent memory over fabrics today have its challenges. And he talked about switch-centric architecture, then went on with definitions of how moving to a switch-centric architecture has some advantages. Rob Davis came up from Mellanox, talked a lot about the kind of persistent fabric support that's available today. RDMA is available today. Why? It's got low latency, 0 copy. It OS bypass, and it's reliable. How does it do it? It does it through Q pairs. I know that there's discussion about whether Q pairs is the most efficient way of doing it. I think Paul Gruen would probably make that argument. But it's something that's available today, and it's out there. RDMA is good for high availability. Work's going on in the IBTA for PMOF support over InfiniBand, and development platforms are available. Moving through the day. No, I got to finish it. Okay. Telpy came up, Tom, talked about JEDEC work, that's how the JEDEC NVDIMs ends and how that's part of the architecture. Also talked about the PMDK, how it's got full support in Windows and has Windows native APIs are coded into it now. He talked about Windows virtual persistent memory with now has DAX support and supporting migration. Talked about SQL Server 2016. Once again, the tail of the log, and how you're seeing about a 2x performance increase by using NVDIMs across the whole application. Storage space is direct, multiple servers acting together to really expose one kind of unified server platform, and PM support has been added to that as well. And then finally, he also touched on SMB support, and now having PM support, SMB. Next on, Eden Kim came up and talked about some synthetic benchmarks that have been ongoing, of course, and then after, for the first time, really getting to work, it's these application workload-specific benchmarks. He put up the data. The MVDIMs were off the charts. It was about 3 orders of magnitude, I remember, faster than the using an NVMe SSD, but that was without any kind of flushes. Then later on, he came on and introduced 3 types of flushes, or 3 analysis of flushes. One is no flushes at all, which in some environments is perfectly acceptable, or very, very rare flushes possibly. The next one was an every 4K block transfer that he was doing, was a flush at the end of it, and finally was a flush for every write. And we saw the performance impact of those flushes, and how in some cases, some of the workload ones actually, it narrowed down to very, very close to each other actually. Rich Bruner came up and talked about VMware support, really strong endorsement that VMware is fully behind persistent memory. Did not give a date and said he couldn't, but he implied, I think, strongly that we are getting close to seeing native PM support in VMware, which is really quite good. He talked about one benchmark that they did went from hundreds of microseconds to hundreds of nanoseconds, 3 orders of magnitude improvement. Once again, that's not a little bit of a thing here. He talked about vCenter and how it could automatically allocate the work. I'm not going to go into a lot of detail. I'm trying to go fast. Then after we had the application, so I'm going to have to say, Jack, in the program committee, and there's a few of you sitting here, we gave Jack absolute hell for having this be a panel. We really wanted it to be a lightning talk, and Jack kind of stood up and said, this was just like last week. He said, sorry guys, I set it up as a panel. I'm not changing. You could yell at me all you want. I mean, I don't know exactly, but Jack took a pretty strong position, and he showed us all up. That was a great panel. That was, I think, for me, the highlight of the day. So heads up to Jack. So DreamWorks came in and made the opening comment that they're not here to speed up computers, they're here to speed up humans. So the great quote there, I loved it. Oracle talked about Exadata, data tiering, how they got over 1 million IOPS with 0% CPU usage. Once again, quite talked about in-memory computing, and he popularized Andy and Dan's telephone numbers and made this a scarce resource on the planet. Aerospike came in very, very interesting. Petabyte scale database with a flash-only infrastructure. Requires RAM for the indexes. So the RAM is the issue. By using persistent memory, they can move the indexes from RAM to persistent memory. And they were able to have 2 to 4 terabytes of RAM-like media. And the reboot went from many minutes to 6 seconds. So once again, incredible results. GridGain came up, reiterated. The first remark was, everything that they said applies to us as well. He had a few more things. He absolutely need byte addressability. Java support is required, and once JVM is real and being used, that's going to be a game changer for them. I did ask them the question if they're part of the open source project for the open source PM JVM. They have not. So I think they're waiting for us to make it real, so that's our job to do. DreamWorks, they want to decentralize animation. Currently, their artists are able to process 8 seconds of video per week. What's that? Just the animators.
Yeah, the other 11 departments have their own one.
Okay, just the animators, sorry. And how by parallelizing this, having a central database with the whole thing, they could see what's before, what's after, they could work more collaboratively and really impact the throughput of this. Both DreamWorks and Oracle agreed that tiering must be standardized. There was talks about tiering. Aerospike said they were much less interested in tiering. What they really want is better orchestration and mechanisms to do the tiering. The next question, I think, what's more important, persistence or capacity? Oracle said, well, their real focus was RDMA, getting RDMA to work effectively. However, DreamWorks came in and said, big is important, fast is important, persistent changes everything. So I'm getting a nod, so I got it right. And Oracle also said encryption is also key. GridGain, faster block does not exist. Said, as far as we're concerned, there is no such thing as block storage. Making block storage faster still does not exist. It's byte access or it's nothing. So, what an interesting, the great talk. Jack asked the question, what do we need to do? What do we need to watch, or how can we screw up? The answer was make it cloud first. Don't make it data center. A comment, we don't want to wait for Dell and HP to come up. We want to put it in the cloud. We can start using it right away. Possibly cloud only. So those of you data center guys in the room, sorry for the bad news. You can blame them. They're your customers. They're the customers. Alex said that, what happens when you realize that PMOF is just block size of 1? And I think, is Alex still here? He got crucified. Yeah. So he said, some of the comments, there are no such things as file systems, only databases. Load store is king. Then the question, private versus public cloud, what's more important to you? It was public cloud times 4. I get a comment from Jenny after. There was many, many more praises to Andy. Jenny came to me and said she's going to supplement her income by selling Andy's phone number. There she is. And S.W. Worth says, when is Andy going to Stockholm to pick up his Nobel Prize for computer architecture? NVDIM's Brett Williams and Per Brashers came in. Very, very different point of view here. They said, block, they're the sole providers of saying that let's just keep persistent memory as block access for a while, and it's all about making it a faster tier of block. They talked about how we need data advisories that train data center operators where to put the data, which tier to put it in. And NVDIMS will just basically be one more faster tier of block storage. Okay. Dan Williams came up, we're getting near the end here. Talked about, did he leave? Good. He was too smart for me. So I grabbed onto a few things. Talked about some new things like machine checks and RAM copies, page tables, and larger blocks. He didn't go into the ultra larger blocks though, like Microsoft did. So Microsoft, you're leading in the block race, the Cold War of block size race. MapSync, Andy made him keep his hand on the third rail, and maybe that's why he's not here anymore. And then finally the lib NVDIM drivers, which is a standard driver that works for all the NVDIMs. So we don't have to have proprietary NVDIM drivers. And how the DAX is the same. Future media, I think this is about the end. Carbon nanotubes, Bill Gervasi came up. Bill's here. It's basically a resistive element. It has DRAM performance. It's persistent and very, very low power. As comparing to NVDIMS, it's twice the capacity simply because of the board area. Not having to put 2 types of media down. You could put twice as much media on it as the DIMMs. Also no battery and much quicker for save and restore. It's kind of his highlight. Then we had Andy Walker came in from Spin Transfer, talking about MRAM, embedded focus, focus areas of embedded on-chip CPU and filling in the gaps. Construction is magnetic layers of variable resistance. There's this ongoing issue of basically retention and endurance. In order to make it retention, you have to use higher voltages. That kills the endurance. Many companies have been working on this problem. Spin Transfer believes that they have some new technology that increases this problem by 6 orders of magnitude. So they were obviously very, very happy and proud of that accomplishment. So we'll look and see where that continues to go. Then finally, the new interconnects. By the way, I'm not going to go through the analyst panel because you just were up here. And the new interconnects, C6 was very, very much focused on coherency. They talked about a number of topologies, for instance, processor to accelerator, processor to memory. Then they had direct access arrays and mesh to like all kinds of devices, memory, accelerators and processors, so you can make rich configurations. Then Jeff Cichilli from OpenCAPI from IBM came up to talk about OpenCAPI. He talked about, it's really beyond memory, plus storage, plus accelerators. He said coherence is not there right now, but coherence will be coming later. There wasn't a timeline on that. Low latency, high bandwidth, of course. These are very common across all of these 3 new buses. Tight coupling with the bus and the processor, probably tighter than the other 2. Maybe that's their differentiation. And it's very asymmetric. It kind of reminded me of the USB days. It sort of took all of the complexity and put it into the microprocessor so that you could put relatively simple endpoints on it. It's a different, not a true peer-to-peer equal kind of bus, but one where you have a small number of processors that could absorb that complexity. Finally, Mike Krause came up, did a great job talking about Gen Z. Doesn't surprise me. Mike's a very smart guy. I've known him since we started the original PCI bus, the parallel one, not the stereo one, many, 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 many years ago. So Gen Z is a memory focused, and from a persistent memory forum, obviously there should be a lot of affinity towards that. A very memory focused, memory centric focus, high performance, low latency. Base infrastructure doesn't change. It kind of slips in very, very easily into existing storages, areas. It's low stored memory access, and it could be also done at the rack level rather than just the data center level. And feels that you could, you can't, this is not going to happen load store across the data center, but at a rack or 2, possibly they know how to do that. Talked about the electricals, leveraging on PCIe and 802.3 electricals. And finally, it's also focusing on persistent memory, specific memory semantics. So that is it. How did I do on time?
That's all?
You went over.
I went over. But you started me way late. Anyway, for those of you who came and stayed to the end, I want to thank you very much. I hope that this was an enjoyable day for you. We jammed a lot of stuff in it. I want to thank the committee. Many of them are sitting over here who helped put together the curriculum. And we all owe Jack a beer for you beating him up and having him show us up. I'd like to thank.
Well done, Jim.
I'm the figurehead here. So Marty did a boatload of work, and I'd like to thank Jenny for emceeing the advice. And Jenny ran all the meetings to get this ready. So thank you.